So today we're going to start working with right triangles a little more in detail. We're going to start with the Pythagorean theorem, which tells us how to find missing sides, knowing the other two sides. And then we're going to move into right triangle trig. But today, Pythagorean theorem is where we are going to begin our study. So this is a right triangle. You can tell because it has a right angle. A right angle measures 90 degrees. The side across from the right angle is known as the hypotenuse. So if you know where the right angle is, you can identify which side is the hypotenuse. The other two sides are known as legs, and it doesn't matter which leg is which. You can call one leg 1 and one leg 2. The order doesn't technically matter, and you can find the missing side of a triangle using what's known as the Pythagorean theorem. Which says a squared plus b squared equals c squared. In other words, the sum of the legs squared will equal the hypotenuse squared. So let's take a look at a few examples. Firstly, we have a right triangle whose legs both measure 5 and 9, and we don't know the measure of the hypotenuse. So if we look at the Pythagorean theorem, in this case, the unknown value is our hypotenuse, which we said is c. So c is going to be x. A can be 5 squared, and b can be 9 squared. Now, it wouldn't matter if we switched the order of these, if we made it 9 squared and 5 squared, because you add them in either order, you get the same result. So we're going to simplify this. We're going to get 25 plus 81 is equal to x. When you add these, you're going to get 106 equals, x squared. 106 equals x squared. Now to find x, we're going to take the square root of both sides. And the square root of x squared is x, which is what we are looking for. Is x, which is what we are looking for. And the square root of 106 is a decimal we can calculate with our calculator. So let me go grab my calculator right now. And I'm going to type into the calculator the square root of 106. And we get 10.2956. You have to pay attention to what questions are asking you to do as to where to round. I didn't provide that in this problem, so if I said round this to the nearest tenth, it would be 10.3. If I said round it to the nearest hundredth, it would be 10.3 as well, because the 5 would round the 9 up to a 10, which would then round the 2 up to a 3. And if I said round this to the nearest thousandth, the 6 would round the 5 up to a 6, and we get 10.296. Now, often you'll be asked to write your answer in what's called simplest radical form. I'm not sure 106 is a number that has a simplified radical, but we'll take a look. If you want to write a number in simplest radical form, you have to divide it, you have to separate it into two numbers that multiply to be that number where one of them is a perfect square. So going through the list of perfect squares, which are 4, 9, 16, 25, 36, 49, and so on, we're going to try and see if any of these go into 106 evenly. If they don't, that means that we cannot simplify this number. So 106 divided by 4 is equal to 26.5, which means it doesn't divide evenly. 106 divided by 9 is equal to 11.7, which doesn't divide evenly. And I guess any other number bigger than that would probably not make sense to check. So this one probably does not simplify any further. So x equals 100 and radical 106 is probably considered the best answer for this problem. Let's take a look at another example. In this case, the right triangle is not drawn in a standard way, but that doesn't mean that the problem's solution method changes. The side across from the right angle is still the hypotenuse, meaning this is still our c value, and the other values can be a and b. It doesn't matter which one is which. So we are going to start with the Pythagorean theorem. So a squared plus b squared equals c squared. A will be 8 in this case, so 8 squared plus, in this case b is x, so we'll call that x squared equals 20 squared. And we're going to solve for x. So in this case, one of the legs is unknown versus the previous case where the hypotenuse was unknown. Technically, these problems are slightly harder, but very slightly. So if we square 8, we get 64 plus x squared equals 400. We're going to subtract the 64 to the other side, and we're going to get x squared is equal to 336. Now we're going to take the square root of both sides, which gives us that x is equal to the square root of 336 which I believe does have some perfect square factors. So I'm going to try and divide 336 into other numbers. So 336 divided by 2 is, I think it's 188, let me confirm. 336 divided by 2 is 168. If I divide 168 by 2, so this is a prime factor of 336, and divide it by 2 again, and we get 84. We're going to divide it by 2 again, and we're going to get 42. We're going to divide it by 2 again, and we're going to get 21. And we can divide out a 7. So these are the prime factors of 336. So we could rewrite this as x is equal to the square root of 2 squared, 7 and 3. And the reason I write it as 2 squared is because the square root of 2 squared is going to be 2. So this comes out as a 2. The square root of 2 squared is a 2. And 7 and 3 are not perfect squares, so they will stay inside as a 21, meaning our simplified answer will be x is equal to 4 radical 21. You could use a calculator to get a decimal as well, but this is the simplest radical form. So simplest radical form means that the radical itself cannot contain any perfect squares. So because we had 4 2's, which is equal to 16, really this problem could have been simplified by saying radical 336 is equal to radical 16 times radical 21, and the 16 would become a 4. So this is the alternative method of doing this. I like the prime factorization method. Let's take a look at a few examples of simplifying radicals. Radical 80 can be rewritten as radical 16, which is a perfect square, times radical 5, or 4 radical 5. It also could have been rewritten as radical 4 times radical 20, which is equal to 2 radical 20. The problem with this example is that radical 20 still has a perfect square factor, so this one is technically not in simplest radical form. If you wanted to continue, you have to factor out a 4 and a 5, where this will become 2 times radical 5, which is 4 radical 5. So moral of this story is that if you want to simplify a radical in the fewest steps possible, you want your initial choice of the perfect square factor to be the largest one possible. Otherwise, you'll have to do it once, and then you'll have to do it again until you have no perfect squares that can be factored out of the remaining number. Let's take a look at 600. Well, 600 can be rewritten as 100 times 6. The square root of 100 is 10, radical 6. 6 is not a perfect square, and its only factors are 2 and 3, which are also not perfect squares. So we're going to be finished right here. And last one we have here is 245. Off the top of my head, no particular numbers stand out. So let's use the prime factorization method, which is useful when you're really not sure what numbers to divide by. So 245 clearly is divisible by 5 because it ends in a 5, so I'm going to factor out a 5. 245 divided by 5 is equal to 49, which is a perfect square. So we could stop there, but just to demonstrate the factoring method, I'm going to factor that completely. 7 is a prime number. So this can be rewritten as 7 squared times 5, and the square root of 7 squared will be equal to 7. So this final answer here is 7 radical 5. Oh, and we have radical 33. Radical 33 is the same thing as, well, 33 breaks down to 3 times 11, neither of which are perfect squares, meaning that this problem cannot be simplified because the radical itself contains no perfect squares. And there's going to be some practice problems on delta math. If you have any questions, make sure to ask in class on Tuesday.